So for alkane, given the fact that it's inert and unreactive, there are only two chemical reactions that you can undertake, and both these reactions need harsh condition, so like high temperature or otherwise radicals to trigger them. So for cracking itself, catalytic cracking, it will only take place in the presence of silicon dioxide or aluminum oxide, and at a high temperature of 400 to 500 degrees Celsius, and the alkane molecules will start breaking down to smaller one. Alongside it, you could produce alkene, and aside to that, the second possibility for cracking is when the alkane molecule becomes an alkene molecule plus actually hydrogen. Let's take a look at a couple of the reactions. So for example, if I were to start off with C7H16, your heptane, we put it into undercracking. So in terms of the possibilities is that you might actually produce ethene, and then if you were to balance the rest of it, this will be your pentane. Okay, so the other possibilities is that you will find that you can have a larger alkane molecule, and this will end up as butane. Similarly, you will get the C4H8, and this will be your propane. And if you get a pentene, then you will end up with ethane. Okay, so one more time. So a good example of cracking will be to look. So an example of cracking. So let's take a look at an example of cracking. Say we crack. Say we put heptane under cracking. So these are the various reactions that could take place. So what typically we do as a technique is that we start off, we're looking at the smallest possible alkene first, and then we slowly bring it up. And as you probably will realize, these are all the listed possibilities. Beyond this part, what you now need to do is that you can take each of the alkane and break it further down, which means that, and of course, okay, with all these, so in all these examples that we gave, it is actually in the cracking of the alkane, in all these examples that's listed here, it is producing an alkene plus a smaller alkane. So take a look at the final one, whereby you can take actually any alkane molecule to break it up to an alkene plus H2. So in this case, you can add up, you can produce your heptene and your H2 gas. So these are all the possible products that can be produced when we put heptane under cracking. Also be mindful that there are certain questions that will also there are certain questions that will require you to know that all these alkane molecules that are produced could undergo further cracking. So for example, in this case, this pentane can undergo further cracking to produce another alkene, which is actually your ethene plus your C3H8. So therefore, the final product for this will end up to be 2 ethene molecule and 1 propane. We have completed studying catalytic cracking. All right, let's take a look at free radical sub. Free radical sub typically will have 3 stages. The stage 1 is called initiation. The initiation reactions is when chlorine undertakes homolytic fission, which means it needs UV light to exist it. Bear in mind that all radicals are in gaseous states. So this reaction takes place when all of them are in gaseous states. After the free radicals has been produced, or the chlorine radicals have been produced, the next step that happens is propagation. In any propagation reaction, bear in mind that it means that you will always have a radical colliding with actually a molecule, and the output or the final products will be end up producing a radical with another molecule. One of the important steps that we use to identify that this is a propagation step is when, for example, a chlorine radical collide with an alkane molecule, then what happens is that the alkane molecule or the organic compound will now become the radical, and you will end up as producing HCl. Okay, you can see that consistently as a step. Or you will realize that if you actually have an organic compound, which is a radical, when you collide with a chlorine molecule, then the organic compound which was originally a radical, will end up becomes a molecule, while your chlorine molecule will now becomes a radical. Okay, so that's propagation. So what propagation does is that you will always have one molecule reacting with a radical to produce the radical and the molecule, which means that's how the reactions continue to propagate, very much like wave, so it never stops. Termination step describes when two radicals collide, because when two radicals collide, you actually end up with a covalent molecule. That's when the reaction will cease. Okay, now let's take a look at the enthalpy, all right, of each of these reactions that takes place in free radical sub. The first one that we look at is your initiation step. In the initiation step, you need to break the C to Cl double bond. So obviously it's endothermic, which also explains why the UV light is essential. And bear in mind, as I said earlier, in the exam, if asked what is actually the reagent that's required, we should state that it's Cl2 gas. If you say it's Cl2AQ, then that will not be correct. Okay, let's now take a look at the ethane molecule. The ethane molecule is colliding with actually a chlorine radical, which is much bigger. So there's actually two possibilities that could happen. One possibility is obviously the chlorine radical kick out the H radical. That means the Cl go in to replace the H. In this case, hydrogen radical will be produced. So if you take a look at the enthalpy change of this reaction, you realize that it's endothermic and hence non-spontaneous. So this reaction will not occur. Okay, next. So the other options is that when chlorine radicals collide with methane molecule, it will actually bind with the hydrogen and as to form a molecule. So in this case, you will see that your methyl radical would actually be produced. In this case, if you work out the enthalpy change of the reaction, is exothermic, so energetically favorable. Also important to note that once you form the methyl radical will now collide with your chlorine molecule to regenerate the chlorine radical. So hence chlorine radical, not only is it reactive, it also fulfills the role as a catalyst because it gets regenerated and it can allow the reactions to continue to convert more of the alkane molecules to become halogenol alkane. The other terms that we want to highlight is that in free radical substitution, you may have mono substitution. In mono substitution, what you get is that you will produce CH3Cl from CH4. In di substitution, means two of the hydrogen is now replaced to form Cl. So the product that you get is your CH2Cl2. In tri substitution, you start with CH4 and you end up with CHCl3. Finally, let's take a look at the termination step. For termination step, one needs to bear in mind that the enthalpy change of reaction are all exothermic because they are bond formation. And since they are bond formation, they will occur spontaneously and they are energetically favorable. One key thing to highlight is that at times you cannot prevent the fact that two alkyl radicals could collide with each other. This is when you get an extension of the carbon chain in the final product. This is obviously not the product that you intend to produce because for free radical sub, the idea is not to extend the carbon chain. So mindful that in exam questions, if they ask whether such product could be produced, the answer is yes. You do get products with carbon chain longer than the alkane molecules that's been used as a reagent.